Good morning. Today I am going to discuss critical regions. How do we avoid race conditions? The key to preventing trouble here and in many other situations involving shared memory, shared files, and shared everything else is to find some way to prohibit more than one process from reading and writing the shared data at the same time. Put in other words, what we need is mutual exclusion. That is some way of making sure that if one process is using a shared variable or file, the other processes will be excluded from doing the same thing. Here, it's because process B started using one of the shared variables before process A is finished with it. The choice of appropriate primitive operations for achieving mutual exclusion is a major design issue in any operating system and a subject that we will examine in great detail in the following discussions. The problem of avoiding race conditions can also be formulated in an abstract process is busy doing internal computations and other things that do not lead to race conditions. However, sometimes a process has to access shared memory or files or do other critical things that can lead to races. That part of the program where the shared memory is accessed is called the critical region or the critical section. If we could arrange matters such that no two processes were ever in their critical regions at the same time, we could avoid races. Although this requirement avoids race conditions, it is not sufficient for having parallel processes and efficiently using shared data. We need four conditions to hold have a good solution. This may be simultaneously inside their critical regions. Number two, no assumptions may be made about speeds or the number of CPUs. Number three, no process running outside its critical region may block other processes. And number four, no process should have to wait forever. In abstract sense, the behavior that we want is shown in this region B attempts to enter its critical region, but fails because another process is already in its critical region, and we allow only one at a time. Consequently, B is temporarily suspended until time t3, A leaves its critical region. Eventually, original situation with no processes in their critical regions.